3. So the basis of this problem is just kind of looking at circular motion and the end of the moment problem is a solution and kind of how this works. Okay, so the questions are, two blocks which can be modeled as a point mass are connected by a massless string. Tube extends out of a hole, yada yada yada. The masses are, block 1 is the distance of length from the center of the frictionless surface, and how much time is required, centrifugal force required for G. Okay, so first off, we kind of write down our variables. So for M1, we have 1.1 kilograms. M2, we have 2.8 kilograms. Radius, 0.45 meters from center of the frictionless surface. So we have our diagram right here. We have tension on this object. And we have our work shown, and we're kind of wondering what's the basis of the screencast for this number. What are we really trying to show in this problem? And we kind of want to ask ourselves some specific questions. So, what's a period? So, first off, a period is the amount of time that is required for an object to make one revolution around a circle. So, and to find the period, you do 2 pi r divided by the velocity required for the object to make one revolution. So, what object is moving in a certain direction? What provides the force? The force is tension. And also, kind of important to think about the centripetal force that is also required. And centripetal force is only present with tangential velocity, so they kind of go hand in hand, so that's important to keep in mind. So the tangential velocity is the linear speed of an object moving along a circular path. A point on the outside of an object of a turntable moves a greater distance in one complete rotation, or period. Period is the length of time it takes an object to create one revolution. So, just to kind of quickly explain my work, first I started with 2 pi r, which, like I said, is the period. And I kind of realized, okay, how could I add my variables? So I first did mg, which is just mass 2 times 9.8, because it's just the force of gravity. And I then, and that gave me 27.4 newtons. And then I did the velocity of mass 1 to help find the time. So I just put the force divided by, so mg divided by times the radius divided by the mass. So I got, which is up here, kind of running out of time, and I got 3.3505. Then I plugged that into 2 pi r divided by v, and I got, I did that times the radius divided by 3.35, and that gave me this number. So takeaways are kind of, tension is what's required, tangential velocity is the object moving in a circular motion, so we have to have circular motion required, and tension is also present, and that is kind of what keeps the object moving. Hopefully this helps.